In this activity, you'll work with integer data stored in a two-dimensional array. Some programming languages use a one-dimensional array to represent a two-dimensional array, with the data in either row major or column major order. Row major order in a 1D array means that all the data for the first row is stored before the data for the next row. So if you look actually down below here at this example, if this particular table was stored in row major order, notice that the first three values are 1, 2, and 3, and that's this first row. And then after that is the next row, right? You can see the 4, the 5, and the 6. 4, 5, and 6. Now contrast that with column major order, the situation below here, and you can see if your data is stored, again, this is a one-dimensional array, but if it's stored in column major order, notice the first two values are the 1 and the 4, and that corresponds to this column. And then the next two values are 2 and 5, and that's this column. And then the 3 and the 6, and that's the final column. So, row major versus column major. Let's continue reading up here. Column major order in a 1D array means that all the data for the first column is stored before the data for the next column in the 1D array. The order matters because you need to calculate the position in the 1D array based on the order, the number of rows and columns, and the current column and row number indices. The rows and columns are numbered, indexed, and often that numbering starts at 0, as it does in Java. That's not a surprise for us. The top left row has an index of 0, and the top left column has an index of 0. The row numbers index increases from top to bottom. So as we're looking at this, as we're going down here, the row numbers are increasing as we go from top to bottom. And the column number indices increase as we go from left to right. And that's what we saw when we were looking at the pictures in the last activity, rather. If the 2D, when we discussed this, so you can see again, if all of these numbers were stored in row major order, you can see that we've got a row and then another row. If that same data was stored in column major order, you can see, first of all, yes, it's got it has 3 columns, and every single column contains 2 rows. So you can see there's the first column, there's the second column, and there's the third column. Java actually uses arrays of arrays to represent 2D data. And we can do it with a one-dimensional array, but I think this feature of Java is a lot more useful. That means each element in the outer array is a reference to another array. And we've seen this with our multiplication problems. So the AP Computer Science A course specification tells you to assume that all 2D arrays are row major, which means that the outer array in Java represents the rows and the inner array represents the columns. So a row major 2D array left and a column major 2D array at the right. The following table shows the Java syntax and examples for tasks with 2D arrays. Java supports 2D arrays of primitives and object types. So, for example, in our Magic Square one, we were doing a two-dimensional array of integers. You could do a two-dimensional array of strings, but it's always the type of thing, and then the fact that there's these square brackets and another set of them basically says it's a two-dimensional array, an array that contains arrays. If you want to create a new array, basically say the type and then how many rows, how many columns, and you can see this declaration right here. The keyword new is needed, right? So how many rows, how many columns it has. If you want to access an element in the array, give the name of the array, what's the array name, and then give it the specific row and column. Set the value of an array. So here's the array. We're going to take this value and we're going to store it into the array at that particular row column location. Get the number of rows, If we're getting the number of rows, remember this is row major, so the first thing is how many rows does it contain, so just plain old dot length. And then if you want to get the number of columns, basically what we're doing is we're accessing the first array stored in the outer array, right? So the 0th one, and then what's the length of that? So that'll tell me how many columns it contains. To loop through the values in a 2D array, you must have two indices. One index is used to change the row index, and one is used to change the column index. You can use nested loops, which is one for loop inside of another for loop, to loop through all the values in a 2D array. Here is a method in the intArrayWorker class that totals all the values in a 2D array of integers in a private instance variable field in the class named matrix. Notice the nested for loop and how it uses matrix.length to get the number of rows and matrix at 0.length to get the number of columns. Since matrix at 0 returns the inner array, right, in a 2D array, you can use matrix at 0.length to get the number of columns. And again, if this particular thing had, like, if it had 12 rows, you could use any one of them, but we just typically grab the first one. So this is something that we've totally seen before. This is a traditional, just a for loop where we're beginning at row 0 and column 0. And while it is less than the length, remember if the length was 12, this would be the number 11, right? The last value row would take on would be 11, which is right because 12 things would be indexed from 0 to 11, right? So this is the minimum and this is the maximum index if your matrix contains 12 elements. And you can see each time in here, it's initialized this variable total to 0, and what it's doing is it's grabbing all the values in the two-dimensional array, and it's saying total is what total currently is, plus the current value stored in row column, that matrix at row column, and then it returns that total value at the end. So if I was considering this particular array, and I wanted to run this, by the way, this is not the number 11, that's just a 1 in that box. Notice how this works, right? The outer loop begins with setting what row number is, so I'm going to start at row 0, and then inside of that loop, I'm going to go and hit all the values of column. So the very first thing that I'm going to encounter is the number 0, and you can see right here where it says matrix at row column, that's going to be stored into total. Total starts out at 0, and the very first value I put in it is this number 0. So it's still 0 because I just added it. Then column increases by 1, so now the next value would be a 5. So now total would be 5. And then again, the column number inside of this inner for loop increases by 1. So now the current row matrix value would be 3. 5 plus 3 is 8, so my total is 8. Now, I've completely gone through that entire row, getting all the column values, right? Column 0, 1, and 2 for that row. Now I begin again, and on my outer loop, right, the outer loop now increases by 1, and now I'm looking at the second row. And in my inner loop, what happens? I'm going to hit the 4, the 2, and the 1. So I'm at 8, 9, 10, 11, 12. And then the 12, and then the 13, 14, and then the 15. So now my total is 15. And then one last time, because there is still yet another row. So the outer for loop is triggered again, and then inside of here, I'm going to go and pick up each one of these values. So inside of here, column would be 0, and then 1, and then 2. So I think most of you guys are really comfortable with this. I just wanted to just go through this in case some of you might be struggling and thinking about it. So this is pretty standard. This is what we've been doing for a while now. Because Java two-dimensional arrays are actually arrays of arrays, you can also get the total by using nested for each loops or enhanced for loops. Loops as shown in get total nested below. The outer loop will loop through the outer array, each of the rows, and the inner loop will loop through the inner array, columns in that row. You can use nested for each loops whenever you want to loop through all of the items, and I think that's the, whoops, I don't know why I crossed that out, I wanted to underline it, through all of the items, right, in a 2D array, and you don't need to know the row index or column index. So if you really don't care where things are being stored at or where you're picking them up, if you just want to go through and get all of them, this is a very nice scheme. However, notice my outer for each loop, right? Every single one of these things, it's going to be a row array, right, is going to be of type an integer array. So I've got an integer array, and then inside of that, right, I'm going to be pulling, inside of that, I'm going to be using this row array. That's going to be my data source, and I'm going to be pulling the individual integers out of it. So if you look at it, item is a particular integer stored in the row array. So in my outer for loop, what I'm really talking about is this entire array, right? This entire array with the 5, the 3, and the 1 is what makes it into the inner for loop. So this right here is that array, and in the context of the inner loop, right, that's where I'm reading my elements from. So for the outer for loop, I'm saying grab the entire array, and then the inner for loop is picking out individual integers from that. So in the context here, item would be the individual elements in that array. So the first thing that would be added to it would be the 5, and then the 3, and then the 1. It's going to get all of them. And then I go back out to my outer for each loop, and now I'm grabbing this entire array, and this entire array is making it into my inner loop. So this is where I'm going to be grabbing these integers called item. So I'm going to be grabbing the 6, the 2, and the 4. So again, advantage of this is I don't really need to know, and I actually don't need to know because I can use dot length to figure it out. But if I'm just going to grab all of them, right, and I don't have to worry about index out of bounds errors or anything like that, I'm just grabbing the entire array, and then in the inner for loop, I'm just grabbing each one of the elements from the array and then just adding them to the total. Okay, so there are 3 exercises associated with this section, and basically these are modifications you need to be making to your class. So write a get count method for the int array worker class that returns the count of the number of times a passed integer value was found in the matrix. So there is already a method to test this in the int array worker tester. Just uncomment the method test get count and the call to it in the main method of int array worker tester. Int array worker tester. That's correct. Here, let's try this. I'm going to try and help you see how these are organized to maybe get you through exercise 1. So there's 2 things, right? There's the int array worker tester. This has a main method. This will create an instance of the int array worker, and it'll test out certain features. Now, if you look at this, the instructions say, let me open this up in the editor. Open an editor. The instructions say that it already contains something called, get count. And what this method basically does is it's just to test out and see if the get count method that you write over in int array worker to see if it tests, if it tests out. So what this does is it's going to create an int array worker called worker that will be a new int array worker, and then it's going to create an array of nums that's 3 by 4, and then it's going to set up that matrix. So worker.setMatrix, and here I'm giving it the matrix to set up nums, and then worker.fillPattern, I'm filling this this array up with something, and then int count equals worker.getCount of the number 1. So how many times does the number 1 occur in the matrix? So that's what this method you're writing is supposed to do. So here's the thing. You need to write a method called get count, and this method get count needs to be inside of the int array worker. Now, and what does it do? It basically, you give it an integer that you're looking for, and it's supposed to count the number of times it sees that. So, for example, if I have an array like this, and I ask this method, hey, how many times does the number 3 occur? It would return 0 because 3 never occurs in this array. If I was to ask it how many times does the number 2 occur, it should return 3 because the number 2 occurs 3 times. So if we're looking carefully at the method header, right? The method header should take a single integer, and then it should use that integer as the tool that the value that it's searching for throughout the array to see if it occurs. And every single time it does occur, there should be some counter variable that it's increasing. So again, to summarize, what we want to be doing is looking at int array worker, and inside of there we need to add a method that will return an integer when given an integer. The integer it's given is the target int that it's looking for, and the integer it returns is how many times that occurs. So if I was to go ahead and open up, open up that class, int array worker. Here's the tester for it. That's the driver for it. But here's it. You can see it has several methods already in place that are doing a lot of things, but we're asked to add some functionality to it. So, for example, I could right below this class begin a new class, and it would look something like a public method. So public int, and so it's returning an integer. I'll call this get count, and it's going to be given an integer that I'm going to call, I'll call target, T-A-R-G-E-T. So this is what I'm looking for. And at the end of the day, right, this what this is supposed to do is it's supposed to return a value, the number of times that it finds the target. So I'll just say return 5 right now, meaning, hey, no matter what you're looking for, it always occurs 5 times. We've got to fix that, right? And your assignment here is to write a method that will fix that. And then you're going to test it out with the int array worker tester class that does have a main method in it. And they've already shown you basically what you're going to do to test it. All the code for that's there. You just need to uncomment that out and then uncomment the lines in the main method for it as well. Yikes, this is a little confusing. Good luck with getting through this first exercise, kind of the first exercise that really could cause a little bit of confusion, but we'll get the hang of this, and it won't be long, and we'll be flying through these things.